Hello ladies, in this video we're going to go through 6C, which is the index law number 3 and the zero power. So just in these key ideas, which you should have in your bound reference, key idea number 3, index law number 3, when you've got a base to a power and then a power outside the brackets, you multiply your powers. So just remember your base to a power and then the brackets to a power, you're multiplying those two powers. So when raising a term in index form to another power, retain the base and multiply the indices. Okay, so here's an example. If we had x squared and that was to the power of 3, we would have x to the power of 2 times 3, which is x to the power of 6. And when you think about that, and I might just draw that here, x squared to the power of 3 is the same as x squared multiplied by itself 3 times. And when we multiply, we add our powers. So remember back to, I think it was index law number 1. And then we get x to the power of 6. So instead of expanding it, we can just multiply those powers. So remember, when you've got a power to a power, we just multiply. Oh, I do not know why that all of a sudden changed color. But anyway, there you go. All right, let's just delete that and let's do a few questions. Oh, before we do, the zero power. So basically anything to the power of 0 will always be 1 where a is not equal to 0. Okay, so it's true for any number, whether it's a negative number, a positive number, a decimal, a fraction, it will always be 1. Unless a is 0, because if a is 0, 0 to the power of anything will always be 0. Okay, so apply index law 3 to simplify each of the following. Leave your answers in index form. Okay, so let's just quickly do a few of these. So we've got x to the power of 2 to the power of 5. So we keep our base and, oops, it's a weird multiply sign, and multiply our powers. So we've got 2 times 5 gives you x to the power of 10. Let's have a look at doing a harder one. So let's do f, 7 to the power of 5 squared. It's not really that hard, it's pretty much the same, but we've got now a number instead of a prenumeral. So that's 7 to the power of 10. If we had something like g, we've got 4q to the power of 7 to the power of 4. So the 4 isn't taken to any powers, so that stays. The q is the power of 7, and then that is to the power of 4. So we're going to have 4q, 7 times 4 is 28. Okay, and let's just do maybe h as well. Oops. I keep pressing these buttons on my pen. That's why weird things happen. Negative 3, c to the power of 2 to the power of 5. So the negative 3 isn't taken to any powers, so that just stays negative 3. And then we've got 2 times 5 for our powers. So we've got negative 3c to the power of 10. All right, looking now at question 3. So we're using the zero power here. Zero power. Well, there's zero. I thought I said that wrong, but I didn't. Okay, so let's start off with a simple one. So remember, anything to the power of 0 is just going to be 1. Okay, if we've got a bigger term, let's have a look at something else. Okay, so let's look at I. So I've got 5m to the power of 0. Now, the 5 isn't taken to the power of 0, so it just stays 5. But m to the power of 0 is 1, so it's going to be 5 times 1, which just gives you 5. Let's have a look at k. So we've got 6x to the power of 0 minus 2x to the power of 0. Okay, so remember x to the powers of 0 become 1. So we've got 6 times 1 minus 2 times 1. So that becomes 6 minus 2, which gives you 4. Let's have a look at, maybe we'll just end with L. So we've got negative 5n to the power of 0 minus 8n to the power of 0. So negative 5 times 1. And this whole bracket is to the power of 0, so it's going to be minus 1. So we've got negative 5 times 1 is negative 5, minus 1. So your answer is negative 6. All right, just going to get rid of that so we've got space for question 4. All right, so for question 4, we need to simplify by using a variety of index laws. So I'm just going to do a few here. Okay, let's have a look at question G. So we've got d to the power of 3 to the power of 4 times d to the power of 2 to the power of 6. Okay, so we multiply our powers, so we're going to have d3 times 4 times d to the power of 2 times 6. So it's d3 times 4 is 12, and then 2 times 6 is also 12. Now remember, we're now multiplying our bases. We've got rid of the brackets, so our bases are the same, so we're now adding our powers. So that's index law 1. So we've got d to the power of 24. All right, let's have a look at another one. So I'm going to do maybe I. So we've got z to the power of 4 times z to the power of 3 all squared times z to the power of 5 to the power of 3. Okay. So z to the power of 4 can just stay like that because we're not changing it. Now, we've got a bracket here, so we've got a power to a power, so it's going to be z3 times 2. And then we've got another bracket, so it's going to be z to the power of 5 times 3. So we've got z to the power of 4, z to the power of 6, and then z to the power of 15. Now we're using index law 1, so we're going to have the same base, and we add our powers. So 4 plus 6 plus 15. And that's going to be z to the power of 25. Okay, let's just finish with L. So we've got s squared to the power of 3 times 5 r0 3 times rs squared. I think the biggest mistake you would probably make is not copying it down correctly. Okay, so our base is s, so 2 times 3. This 5 isn't taken to the power of anything, so that can just stay there. Now I've got r to the power of 0, which is just 1, and then going to have 1, and then to the power of 3, then rs squared. Now, just remember, that's not r to the power of 1, it's 1. So effectively, this whole thing becomes 1, which I was going to write, but then I thought, well, in case you didn't notice. So this is going to be 5 times 1, which is just 5. Try not to get your 5s and your s's mixed up. Okay, so we've got r's and we've got s's. So let's do our s. Oh, don't know what happened then. S first, so 6. That's a 5. Oh, so I'm going to write my 5 first. 5s, 6 and 8. 6 and 2 is 8, and then r. Now, probably a good idea to put this in alphabetical order, but you don't have to, because r comes before s. So 5r s to the power of 8. I feel like I've missed something, but I'm going to move on anyway. Okay, let's do question 5, and we'll end the video. Okay, so for question 5, again, we're using a variety of index laws. So let's start off with A, usually the easiest one. Okay, I prefer to write a division like this. So we're going to have 7. Now at this stage you should be writing straight away 3 times 2 is 6. And so this 6 cancels out with that and gives us a 2. So we're going to be left with 7 to the power of 2, sorry. Simplify each of the following. Now, we're not leaving it in index form, that becomes 49. Okay, let's move on to a harder one. Let's do D. M to the power of 3, the power of 6, divided by m squared to the power of 9. Okay, so we've got m to the power of 18 on our numerator, and then m to the power of 18 on our denominator. When you are dividing the same thing, dividing a number by the same number, this becomes 1. Okay, and do one more. Just trying to think what might be the hardest. Let's look at I. My hands are freezing. I always say that. Okay. So we've got y to the power of 3 times 3 over y to the power of 3. Now you could have straight away done some cancelling, but it's probably a good idea to see what you're actually doing here. So this y to the power of 3 cancels and makes that a 6. So remember, a second index law, we subtract our powers. So we're left with y to the power of 6. All right, girls, catch you later.